Thank you much. Some of you just heard this in the previous presentation, but this one's about common CEMS audit program audit findings. I'm Eric Wiley, Senior Air Compliance Specialist with VIM Technologies. I've been working in the CEMS related industries for about 23 years. Started as a stack tester, pushing a probe, project manager, then was an instrumentation tech at a local refinery in Southern California. Became the Qaqc manager of that program, and then became the CEMS program manager. And I also took that position at another refinery. But for about past 15 years, I've been doing CEMS consulting related work. So a lot of that has to do with performing CEMS program audits, as well as regulatory training and trying to help facilities figure out how to use their limited resources and comply with the regulations. So that's enough about me. Let's move on to some. So these common findings, we have 10 of them here. There's a couple more in there. Really, it doesn't matter what the industry is. I seem to find the same issues of non-compliance at a variety of different facilities. And we're going to go over what some of those are and maybe ways you can try and ensure that this doesn't happen at your facilities. So the first one is having a non-compliant Qaqc plan. Either the plan's outdated, the plan doesn't exist, or it doesn't contain the specifics that are detailed in the applicable regulations. Also, without question, come across a lot of CEMS performance issues where just the sample is not being conditioned properly, and therefore the system itself is not providing reliable data. And then having a reactive maintenance program. So essentially that means you go out and work on your CEMS when it breaks down, and there's no real preventative maintenance schedule implemented. And generally, when you see a reactive maintenance program, you're going to see a lot more performance issues with the systems. There's no calibration after maintenance is performed. We'll go over the details of that, but essentially, anytime you put your hands on the systems, the CEMS, either the sampling systems or the analyzers, you're required to do a calibration drift check afterwards. No adjustment if the drift exceeds 2 times performance spec. We'll go over what those performance specs are. But in part 60, part of the pass-fail criteria for your daily calibration drift checks is 2 times performance spec for 5 days. And then each of those days that you exceed, we'll use NOx as an example, 5%, you're required to go make an adjustment to that system and then perform a calibration drift check afterwards. There's incorrect CGA or linearity gases. So for a CGA or a linearity test, you're required to use gas concentrations of a certain percent of range. And I found doing audits that sometimes those percents of range, the concentrations don't fall between, so that means the test performed with those gases. So the linearity check is from part 75. So and then the cylinder gas audits for part 60. So they're real similar. The linearity test just has one more gas. So a lot of the refineries, you might have part 75 on the boilers. That's what I've seen. Poor logbook entries, no logbook entries, come across that quite a bit. A lack of training, that's for environmental personnel on the regulations, as well as instrumentation technicians on the regulations, why they're doing what they're doing. A lack of communication between the parties involved. So I mentioned the previous one, but that would be the environmental team, the instrumentation team, and the operators. A lot of times there's a real lack of communication, so those that can lead to some non-compliance issues. And then lastly is relying on a single source of knowledge. So if you have what I've come across in the past is there's one guy who knows everything about the CEMS, how to take care of it, what QA tests are required, and then that guy leaves and there's no one to fill his shoes and that knowledge is gone. So we'll start with a non-compliant Qaqc plan. One of the first things an inspector will ask for or may ask for is their quality assurance plan. So if you don't have a quality assurance plan, or you have a quality assurance plan that's outdated and doesn't have the required procedures and or the existing equipment in it, that can be a red flag to inspectors. Frequently, the condition of your Qaqc plan is indicative of the condition of the CEMS program as a whole. So if you have a non-compliant Qaqc plan, that's going to put a light on, and those inspectors are probably going to dig a little deeper to find other areas of non-compliance. An obsolete Qaqc plan. So sometimes I'll get a QAQC plan to review for an audit, and I can see that it hasn't been revised in 10 years. And so the equipment that's actually in that QAQC plan no longer is at the facility. It'll lack the required maintenance and QA procedures. So for in your QAQC plan, there's specifics that detail where procedures are required. So procedures are required for any calibration adjustment, any maintenance procedures or preventive maintenance procedures, a spare parts list, and response to a malfunctioning CEMS, as well as procedures for any preventative activities you do. So that could be a variety. You may have a monthly, quarterly PM that's done, or a quarterly PM that's done, and those procedures and or checklists are not included in the QAQC plan. So again, the biggest component of the QAQC plan should be the procedures that are utilized so that your CEMS systems can generate reliable, accurate data. CEMS performance issues, there's a variety of them. It depends what type of CEMS systems you have. So there's dry extractive CEMS, which means there's a vacuum pump at the bottom. He pulls the sample out of the stack, keeps it heated above its dew point, and then it goes into a chiller, and that chiller removes all the moisture out of that sample, and then a clean, dry sample is sent over to your analyzers. That's how it's supposed to work. But a lot of times you'll see sample system malfunctions where the moisture is not being removed from the sample, and then you have a wet sample that's going over to the analyzers. And then once an analyzer gets water inside of it, it's like chasing your tail. It's going to lead to more and more performance issues and replacement of parts within the analyzer. So it's highly important to keep the analyzers dry. Keep the sample that's going to the analyzers dry. A lot of times as well, there's analyzer faults or alarms that are displayed that maybe aren't being captured by the DAS. And then if there's a fault or an alarm, that means that the analyzer is operating outside of its manufacturer specifications. So again, that can lead to inaccurate data. And then if you have frequent daily calibration drift check or error results, that means you're failing the daily cal, you're generating a lot of invalid data, and the system's really not performing up to snuff. So if you see a lot of failed daily calibration drift checks, that means there needs to be a little more maintenance performed on those systems to try, because the daily drift checks is a really good indicator of how the system is performing. Pardon me. So when we come across reactive CEMS programs, usually there's no preventive maintenance schedule. There's a lot more sample system and analyzer malfunctions or performance issues. As it indicates, maintenance only performs as a reaction to something breaking down. So instead of being proactive and rebuilding a sample pump quarterly, they'll wait till that sample pump diaphragm tears and then it doesn't work properly. So you generate CEMS downtime. And so that's where a preventive maintenance program far exceeds that of a reactive maintenance program. There's a lack of necessary spare parts. I mean, if you don't have the spare parts, you can't make the required repairs. So having a robust spare parts inventory is essential to making sure that the system's performing properly. And then all of these lead to CEMS downtime. So if you have any environmental managers in here or environmental personnel, every quarter you have to do a CEMS downtime and excess emissions report. So if you have a reactive CEMS maintenance program, that means you're going to have a lot more CEMS downtime to populate that report. And again, when you submit reports to the EPA or your local regulator and they see that you have a lot of CEMS downtime, then that can lead to scrutiny on their part. But also, if it exceeds 5%, so if the downtime exceeds 5%, that leads to more reporting from the environmental department. If your downtime's 5% or less, you can just send in a summary report. But if it's greater than 5%, you have to send in a detailed report, which has the details of every time the CEMS system wasn't functioning properly and down. So you have to have what caused it, what was done to repair it, and what was done to ensure that doesn't happen in the future. So the summary report is literally a table with like 5 buckets of downtime and you just fill it with hours. But if you have to do the detailed report, it's a heck of a lot more work. So there's no calibration after maintenance. So when I was a technician, I wasn't aware that you had to do a calibration drift check after doing maintenance. I kind of tried to use logic, which logic and environmental regulations usually don't go hand in hand. So if I did a major maintenance, say I replaced a sample pump and and put a new filter in, I would go down and run gas and adjust the analyzers, but I wouldn't do an auto calibration drift check afterwards. And so we had a inspector come, and he highlighted some times that occurred. And that's how I learned you needed to do them afterwards. So it's important that not only you do the calibration drift checks after, but that your technicians know kind of why. Because what you're doing is every morning when you're checking, doing the calibration drift check, the system's it's functioning in a certain fashion. But if I go in and replace a sample pump and replace a filter, maybe the vacuum's lower and the flow is higher. So I've changed the physical attributes of that system. So that's why you need to do a calibration drift check afterwards. I mean, what we did is anytime you put your hands on the system, just do a calibration drift check afterwards. That might be a little conservative, but it certainly covers your behind so that you don't have to give explanations every time there's CEMS down or maintenance is performed. And then if there's the data generated after maintenance, if you haven't done a calibration drift check, some regulators will deem the data after that maintenance all the way until the next time a calibration drift check is performed as invalid until you pass one. So it could lead again to a lot of downtime and more of a hassle for the environmental personnel. So for part 60, if you do your daily calibration drift check, you have a 0 or a low level and then a high level. But if it exceeds 2 times the performance specification, which we'll just use NOx because it's the performance spec's 2.5%. So if it exceeds 5%, but is less than 10%, you're not generating invalid data. It's not out of control, but you're required to go out there, not you, but someone's required to go out there and run CalGas, make an adjustment, and then pass a subsequent calibration drift check. And a lot of times when I go to facilities, there's no procedure for this. So some facilities, they might wait 3 days and then go out and do the calibration drift check or the adjustment. But if you have an inspector who's knows what they're doing, this will be one of the things they look for to see if you're doing those calibration drift checks, because essentially you have 5 days to fix whatever is causing the discrepancy. That at the end of those 5 days, data is considered invalid until you pass another calibration drift check. There's another pass-fail criteria, and so if you exceed 4 times the performance spec, this is the black text is from the reg. It says the time corresponding to the completion of the daily calibration drift check preceding the check that results in a calibration drift in excess of 4 times the allowable limit. So what that means is, we'll take NOx again. If you do your daily calibration drift check and the results of that drift is greater than 10%, data is invalidated all the way back to the previously passed calibration drift check. So normally that's a 24-hour period. So you automatically get that 24-hour period of downtime, and then whatever time it takes to pass a subsequent calibration drift check. So usually, depending on the response of the tech team, let's just say 5 hours, you got 29 hours if they get out there within 5 hours, and so on. So it can lead to big chunks of downtime, which can really affect that CEMS data availability. And then what we end up doing sometimes too is go in and we'll have to invalidate that data manually. So it's important to check your DAS programming to see that 4X is usually called 4X OOC. Ensure that that's enabled so that the DAS is automatically invalidating that data instead of having to do it manually. Because if you have to do it manually, it can be easy. It can be easy to miss. So incorrect CGA or linearity gases. You can see here that you have the percents of range that are required for those gases. And what the CGA or cylinder gas audit and the linearity does, it checks the accuracy of the range at multiple points. So every morning you're doing a 0, you're checking the 0, then you're checking the high end of that range. And with a CGA, you're checking at 2 points in the middle. And with the CGA, with the linearity, you're checking at 3 points. So you're verifying that the entire range of that analyzer is accurate. So if the QA test concentrations are outside of the specified percents of range, then the test is considered invalid. I gave an example previously. I had a client, a very big client, who had multiple facilities with the same ranges, so they bought CalGases in bulk, and one of their CGA gases was only 19.2%. And so for, I think it was 6 facilities, had to invalidate data back to the previously passed CGA, And it was a real hassle for them, and it costs them out of their pocket as well. So just make sure that those gases, usually you want to shoot for the middle of those ranges. So 25 and 55%, or somewhere there, give it a little leeway, but you always want to make sure it's above the minimum and the maximum thresholds of the range. So part 60 requires record keeping. It says the date and time identifying each period during which the continuous monitoring system was inoperative, except for zero and span checks, and the nature of the system repairs or adjustments. So it dictates that every time the system's not functioning properly and someone's gone out there to work on it, there needs to be the details of what work was performed in the logbook. I mean, there's no logbook. There's a logbook with like 3 entries in it from 4 years ago. Or there's lots of entries, but it's just like a date and an initial with no detail of why they were out there working on the system, or what type of maintenance was performed. And this information really helps, the logbook entries really help the environmental manager put the downtime into the proper category, because you'll have monitor downtime, non-monitor downtime, unknown reason, known reason, and there's a 5th, I can't think of the name of it, but having this information in the logbook allows the environmental person who's ever doing the report, put that downtime into the correct bucket. Because if you submit your downtime report and everything's in unknown, again, that can be a red flag to the regulators. So you want to try and make sure the details. When I first started as a tech at the first finery I worked at, my boss was we had every entry was a paragraph, it was a little over and above. I'm not recommending you do that, but once I became manager, it was very important to get the necessary information in there. So we would always put date, time, person, and then the nature of the visit, if you will. Just a visual check, everything okay, or sample pump not functioning properly, rebuilt sample pump, stuff into that line, so that when I had to go collect the 28 logbooks from the different units, I could properly assemble the reports. Our DAS has a logbook feature in the DAS itself. So if keeping handwritten logbooks is a little too old school, our DAS has a logbook feature, so you can just log in and put all the information for the visit there, and then it's easily retrievable. So there's lack of training. I know when I was a technician, I was way better at troubleshooting and problem solving on analyzers that I had training from the manufacturer on. I mean, you might have 3 different NOx analyzers and they're using the same technology. They might all be chemiluminescent analyzers, but they function a little differently. So getting training on the specifics of each analyzer makes it easier to troubleshoot, and you can fix problems more quickly, and then again, minimize that downtime and get the system back up and running. Also, a lot of the environmental personnel or the instrument technicians haven't had any training on the applicable regulations. So they don't really know why they're doing what they're doing. A lot of times it's just like, oh, this is how we do it. But there's no explanation as to why that is, or any understanding of consequences if you don't follow the regulatory requirements. Does anybody have any questions, sir? I think communication is a big key, and you see a real lack of communication between the environmental department and the instrumentation team. I think having that open dialogue and clear communication there can really assist in minimizing instances where there might be a breakdown or there might be a performance issue, but the environmental person doesn't know why, what happened, and so there's no communication between the teams, or the instrumentation tech doesn't know the requirements of when do they need to do a CGA, or why, what happens if they start a CGA and they know it's going to fail. Well, in that instance, you still have to complete the CGA until failure, and then make the necessary changes, and then do a new CGA to pass. So just getting communication between those two groups, letting environmental know when there's been a breakdown, can be really helpful in them ascertaining other information that can help make their job a little easier. So many facilities, especially facilities that have 1 or 2 CEMS, they rely on one person to take care of their CEMS. So everything resides in one person's brain, and that person can leave. And if so, if you're only relying on a single source of knowledge without providing training to the other team members, that can be really a disaster once that person leaves, because no one knows how to properly maintain the CEMS or what they're even required to do. So that they can really be in a bind. It can lead to more CEMS downtime, and obviously it can lead to more regulatory violations. So I think the key here is to have that person or persons write procedures on what they do and how they do it, and then show the other newer technicians how to do the procedures and why they're required. You can include all these procedures, like I said before, in your QAQC plan. They're required to be in there, so you can make that plan a real useful tool. But again, I can't emphasize enough to have procedures for maintenance, for QA tests, for what's the response if the CEMS is malfunctioning. You know, those are all requirements, and it's frequently those procedures don't exist. So if, you know, so your old timer leaves and takes all that knowledge with them, it could be a real bind. That's really the extent of my presentation, but I'd like to know if anyone has any questions.